Hey everyone, welcome to this explainer. Look, if you use AI to help you write code, you already know it's basically magic, but you also know the absolute dread of hitting a brick wall when your tools update. Today we're diving into a fundamentally new way to fix those post-cutoff bugs in your AI coding tools. We are going to explore a really fascinating new open knowledge base that acts like a shared memory for coding agents. It's specifically designed to tackle one of the absolute most expensive, time-consuming problems in modern development. We'll break down the exact mechanics of how it all works, check out some incredibly compelling data from a recent blind test, and see how the developer community is essentially becoming the ultimate defense against AI blind spots.
Okay, so let's just jump right into the core of this. If you have ever lost an entire afternoon to a broken build simply because your AI agent sent you chasing ghosts, you know the exact frustration we're exploring today. You know the drill, right? You copy an error message from your terminal, you paste it into your AI assistant, and it spits back this flawlessly written, beautifully reasoned, step-by-step fix. So you implement it. And it fails. You ask again. It gives you another fix. It fails again. Eventually, you realize the AI is confidently giving you instructions for a tool version it has literally never seen. So why does it do this? Why do the smartest, most expensive models on the planet just totally make things up when they don't know the answer?
Well, the root of the problem is something known as confident hallucinations. You see, AI coding agents have a really severe blind spot. They are trained on data up to a very specific date, their knowledge cutoff. But obviously, technology doesn't just stop. A model trained through last year has never seen this year's bugs. So when a brand new build tool version ships and something breaks, the AI is quite literally guessing blind. And instead of just playing it safe, it will confidently invent specific configuration keys that simply do not exist in the real world. It will cite version numbers that are entirely wrong. It falls victim to this bizarre phenomenon where its own predictive logic basically forces it to fill in the blanks with things that sound plausible, but are actually fundamentally wrong.
This really illustrates the massive disconnect going on here. Think about what an AI should do when facing an unseen bug. It should just say, I don't know, I don't have that in my training data. Simple, right? But what it actually does is provide polished, authoritative fiction. If you ask a top-tier model about a brand new bug, it will reason beautifully about the general mechanics of the system. But then, it turns around and recommends fixes that actual human developers in real bug reports tried and explicitly rejected months ago. It gives you a solution that looks so convincing you believe it, and you end up wasting hours just trying to make its hallucination a reality. Now, usually the tech world's response to this kind of problem is to just throw a bigger, more expensive model at it. But as the creators point out, a bigger model has the exact same cutoff. It just hallucinates with better grammar. This is such a crucial point to understand. Scaling up simply doesn't solve the core issue of missing information. If Claude Opus or GPT-4 doesn't have the data, it just doesn't have it. Throwing a premium model at the problem doesn't work because developers just end up paying premium API prices for fixes that were never real in the first place. Honestly, you're just paying more money for a more eloquently phrased lie. So let's introduce the solution we're focusing on today. First things first, let's get the pronunciation right. It is called VidyAgent. That's VIDA-agent. The first part is derived from the Sanskrit word vidya, which means knowledge, and it perfectly rhymes with bidya. So VidyAgent, literally knowledge for agents. It's an open knowledge base designed to be a shared, verified memory for your coding agents, all served through a standard protocol. Notice that it's not trying to make the AI smarter at reasoning. Instead, it's giving the AI a massive real-time library of verified facts to pull from. The entire philosophy behind VidyAgent really comes down to one incredibly simple rule. Solve it once, and every agent gets it forever. Now, VidyAgent doesn't just magically know about brand new breakages on day one. It knows exactly what its human contributors have solved. So the process works like this. Someone, somewhere, hits a brand new bug. They grind through it the hard way, they verify the fix, and they submit it. From that exact moment forward, every single agent connected to VidyAgent knows the answer in seconds. The pain is paid once by one single developer, and then the benefit compounds instantly for everyone else across the entire globe. And, this completely transforms the economic model of AI coding into this powerful cost equalizer. Think about why we actually pay for those expensive models. We pay premium prices because we want their high-level judgment on hard, unfamiliar problems. But here's the secret. A solved problem is not unfamiliar anymore. If an AI can just look up a verified fix, it doesn't need to be this massive reasoning engine. A cheap model simply needs to out-remember an expensive model. It doesn't have to outthink it. If a small model has the right answer handed to it, it easily beats a massive model that's just forced to guess. To prove this wasn't just some nice theory, the creators of VidyAgent ran a really rigorous, predefined blind test.
They actually set up the pass and fail conditions before any data even came in. This was the equalizer experiment. They used 21 real post-cutoff build tool problems. These were actual recent breakages that developers had faced, and they were judged blindly against the ground truth fixes that actually resolved those issues out in the real world. They basically wanted to know definitively, does a small model with a great memory beat a big model operating entirely on its own? The results of this matchup are honestly just staggering. In a head-to-head matchup on those 21 problems, Claude Sonnet equipped with VidyAgent absolutely crushed Claude Opus operating on its own. Sonnet, which is the smaller model, won 17 matchups to 2. Overall, Sonnet solved 20 out of the 21 problems. Opus, the massive, expensive flagship model, solved only 6. And the really interesting part? Opus's failures were textbook confident hallucinations. It gave elegant reasoning followed by completely invented configuration options that real bug threads had already marked as failures.
So, what does this actually mean for your wallet? It really comes down to one single fraction, 1/14th. By doing the token accounting, Sonnet delivered Opus-level fixes at roughly 1/14th the cost per correct fix. That is huge. Both sides of the equation move in your favor here. You are using a cheaper model, and you're getting way more problems actually solved on the first try. It definitively proves the thesis that a small model with a good library consistently beats a big model with a good imagination. But, right about now you might be wondering, couldn't an agent just search the internet for the fix? Well, to test exactly that, they ran a second experiment, putting the same model on both sides. One got live web search, the other got VidyAgent. The agents relying on live web search won 0 out of 21 matchups. Meanwhile, VidyAgent won 19, with 2 ties. Why the massive difference? Because this isn't just basic retrieval theater. Fresh fixes often hide super deep within differently worded bug threads. A standard web search might actually find the right forum post, sure, but the AI still struggles to dig the actual fix out of all the messy, confusing mid-thread conversation. Okay, so how exactly does VidyAgent build this bulletproof verified database? The reason it succeeds where basic search fails is its rigorous verification pipeline. When they say verified, it means something very, very specific here. Step 1, independent confirmation from different people on totally different setups. Step 2, clean environment reproduction. This means taking the bug from scratch and proving the fix makes it disappear entirely. Step 3, human review. And only then, step 4, is it actually published. This pipeline is ruthless. In fact, during their launch, they actually deleted one of the project's own entries because it failed that clean reproduction check. And the community contribution aspect isn't just a side feature. It really is the entire machine. They seeded it, starting with 55 highly verified entries for recent build tool breakage. But it's very much a living system. Any unverified entries are strictly labeled as just leads, so your agent knows it needs to test them rather than blindly trusting them. If a previously verified fix starts failing in new environments down the road, it dynamically loses its verified status. And importantly, if a fix is missing entirely from the library, your agent doesn't just break, it smoothly falls back to its standard behavior. Checking the library first costs essentially nothing. There's this brilliant sentiment at the very heart of this project. They say, somewhere one developer loses an afternoon to a broken build. Everyone after them loses 30 seconds. I love that. That right there is the true emotional core of this tool. It takes one developer's hard-won fix, their super frustrating coffee-fueled afternoon, and it transforms it into a permanent, instantaneous upgrade for every cheap model on the network. It's just a beautiful example of collective intelligence fundamentally upgrading the tools we use every single day. Now, obviously, to fuel a massive open knowledge base like this, you have to have the right incentive structure. So VidyAgent makes a written, permanent promise. Contributors never pay, ever. Proposing fixes, confirming them, reporting the ones that fail, that is all free, and it will be forever. The underlying philosophy is simple. The people who are out there making the library smarter should never, ever be billed for doing so. They are the product, and their expertise is the very thing that makes the whole system function in the first place. Best of all, getting started is completely frictionless, which is honestly exactly what developers want to hear. In fact, it takes about 1 minute. You literally enter one email, and you get a free key right on the spot. No credit card required, no complex account setup to deal with. You just paste a single command into your terminal, and boom, your agent is connected. And since it works with any MCP client, whether you happen to use Claude Code, Cursor, or Windsurf, you're good to go. Plus, the whole shebang is 100% open source, so anyone can go in, read the verification code, or even run their own copy if they want to. As we wrap up this explainer, I want to leave you with one pretty provocative question to chew on. Why are you still paying big model prices for problems the developer community has already solved? Seriously, it might be time to rethink exactly how we use AI in our workflows. It's definitely time to stop paying crazy API fees for confident hallucinations and start leveraging the shared memory of VidyAgent instead. By tapping directly into the verified knowledge of the community, you can get much better results, much faster, and for a fraction of the cost. Thanks so much for exploring this with me today, and definitely consider pointing your agent at this library before your next build breaks. Catch you next time.